So I was asked a question the other day about securing peripheral hosts on a site. By peripheral, I mean network devices that are on the non-safe side, such as IP cameras that are a reachable level or an IP intercom. So then what's stopping a switched on chancer taking the front plate off the IP intercom, taking the uplink cable out and plugging it into their own switch, and then being able to plug their own laptop into that switch and out the switch back into the IP intercom? Then they've got full access to the network, and they can also have the potential to manipulate the relay on the IP intercom to open up the gates. So the example that I demonstrated was the possibility of activating the gate relay switch via the HTTP command. For this though, the HTTP API on this particular intercom needs to be set to insecure on the switch relay out. This is required for some control systems if they want to initiate a HTTP command from the control system to the intercom to initiate the gate relay. Even if the API was set to secure, there could be a weak password against it. Another reason why someone would do this is just to have a snoop around the network, see what they can find, and potentially become a man in the middle and sniff for any sensitive information. Regardless, it's always best to have a little bit of extra security on your networks. We've got a few methods that we can use to help mitigate these sorts of attacks. One of the more secure methods is using a standard called 802.1x, which requires the host on the network to authenticate using a username and a password. 802.1x uses the Extensible Authentication Protocol over LAN, or known as EPOL. EAP is the authentication standard for wireless networks for WPA and WPA2. You can check out my previous video where I attack a WPA network and I go into more in-depth detail about EPOL. 802.1x consists of three parts. We've got the supplicant, which is the client host device, such as a laptop or in this case an intercom. We then have the authenticator, which provides the data link between the host device and the network, such as network switches or wireless access points. Then we have the authentication server, which authenticates the host device to the network based on the credentials that have been provided, whether that's a username and password or a digital certificate. I will be doing a future video on 802.1x. My Draytech 2862 router, which is my main home router, does have an internal radius server feature, but because it's not in my lab setup, I won't be demonstrating it in this video. I do want to go quite in depth with 802.1x, but it might make that video quite long. I'm also going to showcase in that future video the option of having a Windows server set up on there as well as a radius authentication server. This video is going to be aimed more at the residential and maybe even small commercial. Not many residential homes will be running a Windows server, for instance. This method can be implemented across any site without the need of adding additional hardware such as Windows servers, for instance. Of course, 802.1x would be very beneficial in a business or commercial setting, which is why I want to dedicate a whole video to it. In this video I'll be using port security and MAC ACLs at layer 2, and also a couple of other little techniques you can use to help better secure your network. Of course, we all know MAC addresses can be spoofed relatively easily, but this just adds an extra layer of defense to your network to stop any chance of coming along and doing what I've done at the start of this video. The rule of thumb is just to disable unused switch ports. Not even just for intercoms, for anything else internal to the network. So if the customer comes along and he's bought himself a Z-Wave hub and he just wants to plug it into the network, it's not going to work, because as we know, IoT devices can pose a security risk to your networks. The customer not being able to just plug anything into your network just helps reduce that sort of threat. They'll end up calling you saying that their hub isn't working, and then you can go ahead, see what the device is and create a VLAN, for instance, to place that IoT device in its own network. So in my Arachnus 8-port switch here, I've got a Windows laptop which is generating a ping and it's connected to port 5. If I go ahead and disable that port, we can see the ping I'm generating times out. So port security is a feature that limits the amount of MAC addresses that can be learned on a single port. This can help mitigate a rogue switch joining the network and any rogue devices joining the network as well. Going back to my video on ARP and MAC addresses, when a host device is connected to a port and network switch, the MAC address is learned by the network switch of that host, and then it's put into a MAC address table mapping the MAC address to a particular port on that switch. We can therefore tell the switch to only learn one MAC address on that port. So then if a rogue device comes along with a network switch, plugs that switch into the same port, the port's been violated and will shut down. It seems that the Arachnus switches may use some sort of dynamic approach to the port security, so it actively learns that MAC address to that switch port without you needing to input a MAC address manually. On the Arachnus switch, I have a downlink to port 3, which is going to an 8-port TP-Link switch. Now, before I carry on, there are small switches you can buy which power from PoE. So when you unplug the intercom from the switch, plug it into your rogue switch, it'll power up the switch. If the switch in the premises is PoE+, then that small switch, or the rogue switch, can output PoE on a single port. So therefore you'll be able to power up the intercom as well as plug in your laptop to that same rogue switch. If the switch on the premises is not PoE+, then you can easily buy a small battery backup like this with a 3-pin plug outlet, which will happily power a small 8-port switch. But anyway, the TP link is on switch port 3. If I go to the switch web UI and go to the MAC address table, we can see the address of the intercom and my Windows laptop. We want to stop multiple devices accessing that single port. So I'm going to go ahead and disconnect the Windows laptop from my TP-Link switch. Then we go to advanced and then port security, and we have a grid here. By default, port security is disabled. If I enable it and reduce the default MAC addresses from 256 to 1, press apply, and then I'm going to go ahead and generate a ping to the intercom. We can see that I'm getting an ICMP response telling me that the intercom's online. Then Mr. Chance comes along, takes the cable out of the intercom, plugs it into his rogue switch, and then also connects his laptop to that same switch, which is what I'm going to do now. On that Windows laptop, if I generate a ping to Cloudflare, I get a failed response. Okay, so maybe if I remove the intercom from the switch and then reconnect my laptop, the switch will learn the new MAC address and give me access on the Windows laptop. Well, unfortunately, yes, but the intercom's MAC address has been learned in the MAC address table and will stay there for a while, so I can't get access for that time. If I go to the MAC table, we can see the MAC address is still in there for the intercom, and my laptop hasn't shown up. On the Windows laptop though, if I go to the command prompt and do ipconfig, I'm getting no IP address. Maybe I'll do a ipconfig release and ipconfig renew. Nope, I'm not in communication with the router to send a DHCP discover message. Now, after a certain amount of time, usually about 5 minutes, my laptop will eventually have its MAC address learned on the port and then have access to the network. If I reboot the switch as well, it will clear the MAC address table and repopulate with addresses of the hosts connected. If my laptop is connected to the switch and the intercom is disconnected, the laptop will establish a connection to the network and then I can begin to snoop around. But because that port has been configured to only accept one MAC address, we can't have the intercom or laptop simultaneously working on that port. However, let's add another layer of security. We can then tell that port that when a certain MAC address is connected, anything other than that MAC address will not have access to the network. We can do this using a layer 2 MAC ACL. In the network switch, I'm going to disable port security so we can access the whole network from the Windows laptop and then reconnect the intercom. If I go to the Windows laptop, I'm now getting a response from my ping. In the Arachnid switch, I'm going to go to Advanced, ACL, and then MAC ACL. I'm going to create a rule and call it intercom permit. I then have a MAC ACE list, which is the access control entry list, and this is where we set up a rule. So I select the name I created and put it as a sequence 1. This is the order that the rule works if there are multiple entries. The action is permit. We want to permit this device we're creating this rule for. The destination MAC we're going to leave as any. We haven't got a specific MAC address we want to communicate with. The source MAC address here, I'll put the MAC address of the intercom. We then have this source MAC mask. Like an IP subnet, which sets host bits to 0 and network bits to 1 to restrict the amount of IP addresses available on the network, we can set the MAC address mask to further restrict access. So if you're using a network subnet mask of say 255.255.255.252, you're using 30 binary 1s for the network segment and 2 binary 0s. Those last 2 binary 0 values allow you to have a certain amount of host addresses. So a 192.168.1.0/30 address has a 30-bit subnet mask and allows for 4 addresses on that subnet. 2 host addresses of 192.168.1.1 to 192.168.1.2, the network address of 192.168.1.0, and the broadcast address of 192.168.1.3. In a standard /24 or 255.255.255.0 subnet, The network address would be 192.168.1.0. The broadcast address will be 192.168.1.255, and the host addresses available are 192.168.1.1 through to 254. As we increase the subnet mask value, this reduces the amount of hosts that can access the network, so a 32-bit mask will mask the entire IP address and only allow communication from a single IP address. MAC masking is similar. We can set the MAC mask by using hex values. So if I set a MAC mask of 000000000000, that sets all the binary values to 0 and will allow all MAC addresses to communicate on that port. This will be similar to a 0.0.0.0 subnet mask. If I then set the mask to a block of Fs, so FF, 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 then that sets all the binary values to 1. And that's the same as a 255.255.255.255 subnet mask, and will only allow one host to communicate to the network. This could be handy if you wanted a certain OUI or organisationally unique identifier address to communicate. For example, if you had some Snap AV gear and the OUI is D46891 and you just wanted that manufacturer's MAC address OUI to communicate on that rule, you would use a hex mask of FF, 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 000000, therefore setting the D46891 as a block value of 1 and the last 24 bits as a value of 0. But in our circumstance, I want a single MAC address from the source port to only work on this rule, so the device connected must match the MAC address source in the MAC field because of the mask values set. My intercom's OUI is 7C1E B3, and then the last 24 bits are randomly generated. I could then set the value to be 0000000000FF, and this will tell us that the 6th octet needs to match the rule based on the mask. However, I want to do a strict rule, and the MAC address must match exactly, so my mask would be a block of Fs. Any device that doesn't match this rule will not be able to connect to the network. So regardless if the attacker connects their machine direct to this port or via a switch, they won't get access to the network. We then have some other fields we can use. We then have the option to assign this to a particular VLAN. We have an 802.1p class of service, which is used to compare priority against Ethernet frames based on the value of 1 to 7, 7 being the highest priority. Traffic such as voice, for instance, which has a value of 5, or background traffic being a value of 0. Then we have the ether type, which we can specify a certain protocol in a hex value. I press apply, and now I need to assign this rule to a port. On my Windows laptop, I'm generating a ping to Cloudflare and getting an ICMP response. Under ACL, I'll go to ACL binding and assign the MAC ACL to port 3 and press apply. We can see the Windows laptop can no longer ping Cloudflare, and if I try and ping the intercom as well, I get a failed response. Whereas the intercom is happily pinging away. I can then go ahead and log into the web interface. I'm going to go to System, Network, and then Tools. And I can generate a ping. I'm going to just do a ping out, and it gives me a response. Because the Windows laptop has been on the network, its MAC address will be populated in the MAC address table. So I'm going to reboot the switch, clear the MAC address table, and when we log back in, we should only see the intercom's MAC address. So I'm going to go ahead and enable port security on port 3 again. So the intercom MAC address is learned on port 3 and has a strict MAC ACL assigned to it, limiting the amount of hosts that connect to a port at once. Now this method is not bulletproof, and there are ways to get around these features. Because these protocols are working at layer 2 where MAC addresses live, they are susceptible to spoofing. I do have a video on spoofing MAC addresses to access a wireless network, so it'd be good to check that video out. But for most residencies or small commercial, your standard burglar isn't going to be a networking genius or some form of hacker. So this protocol will just be fine for you. This method just helps mitigate anyone just coming along and plugging in a rogue device to your network. I do also have a video on what someone can do once they have access to your network, such as becoming a man in the middle. Other than port security, just make sure that your Wi-Fi passwords are exceptionally strong. If the attacker fails to get a hardwired connection and tries the Wi-Fi, the chances of them accessing the network is going to be very slim. But if they did gain access to your network wirelessly or wired, just stop them in their tracks by changing all the default passwords to something heavily encrypted, but make sure you're using some sort of password database as well so you remember your passwords. I've also seen people configure some sort of VLAN style sinkhole. So they create a VLAN in a high range on the network and assign it to particular ports that aren't in use, and then have an ACL assigned to that VLAN to say that if someone connects to that port that the VLAN's assigned to, it's got no internet connection, and because it's on the VLAN, it won't be able to access any hosts on the rest of the network. So physically, if there are any labels on these peripheral devices displaying the MAC address or serial numbers, some CCTV units even have a QR code. Document them codes, MAC addresses, take a good photo of the QR code, and try and remove them from the actual devices, so then it makes it harder for someone to try and find any sort of information going on the internal network from the devices on the external. So hopefully this has been of some help to help mitigate rogue devices accessing your network. But as I said, it's not bulletproof, but it definitely does have a place in the networking world and provides a higher layer of security to prevent your network from attack.